This is the Snackable GRE Podcast.
Welcome to the Snackable GRE Podcast, Episode 5 by Zeman Review. In this lesson, we will go over the trick to finding the sum of consecutive integers, followed by an example. We will wrap up with our word of the day. One summation pattern the GRE loves is to test adding up all the integers in a consecutive set, which could be something like all the integers from 1 to 11. This is one of those questions that can be very tedious if you try to calculate it manually, wasting time and becoming more error-prone. As always, they're testing whether you can notice the pattern. Here's the formula. Add together just the first and last number in the list. Divide that by 2. In other words, you're averaging the first and last numbers. Then take that result and multiply it by the number of integers in the list. That's it. That's your answer. It's a fairly quick and straightforward calculation. To help you remember it, let's think about this logically. The first step is to take the average of the first and last term, and then you multiply it by how many terms there are. Since these are consecutive integers, the average for each pair of numbers is the same as you work your way from the ends of the list to the middle. Try this yourself with the list of consecutive integers from 1 to 11. The average of the first and last numbers is 1 plus 11 divided by 2, or 12 divided by 2, which is 6. It's 1 to 11. 1 plus 11 is 12, divided by 2 is 6. What about the average of the second smallest and second largest? Well, then you'd go from 2 to 10. Well, 2 plus 10 is 12. 12 divided by 2 is 6 again. It's always going to work out that way. This works because for every pair of integers, you add 1 to the lower number and you take 1 away from the higher number, and so on. So the average remains the same. To finish this formula, it says to multiply the average of the first and last numbers by the number of terms. Well, we already determined that the average is 6, and there are 11 consecutive integers between 1 and 11, so 6 times 11 is 66. That's it. You could list out all 11 integers and add them up, or you could take 6 times 11 and find 66 that quickly. This is even more clutch when the numbers get bigger and scarier, which is what the GRE is likely to do to you. And it's good to know that this formula works whether some or all of the integers are negative instead of positive, as long as it's a set of consecutive integers. It's going to work positive integers, negatives to positive. It doesn't matter. The formula works. Let's take a look at an example. Let S be the set of all consecutive integers from 200 to 1200. What is the sum of all the elements in set S? A, 1400. B, 699,300. C, 700,000. D, 700,700. Or E, 1,401,400. So don't get distracted by all the answer choices. Just use the formula. The first step is to take the average of the smallest and largest integers in the set. That's 200 and 1200. Do that now. 200 plus 1200 is 1400. Divide by 2, you get 700. So there's your average. Now multiply that by the number of elements in the set. How do you find that again? Well, the biggest number minus the smallest number, add 1. That's the formula. You take the biggest number, subtract the smallest number, and then you add 1. Why add 1 again? Because if you simply just subtract the 2, you're actually excluding the smallest integer in the set. In other words, you're leaving off 200, but we need to count it. This is inclusive, right, of the 200 and the 1200. So the total number of integers in the set is 1200 minus 200 plus 1, which is 1001. The last step is to multiply 1001 by the average of 700. You might be able to do that in your head. If not, write it down. 700 times 1001 is 700,700, or answer choice D. Answer choice C is a trap answer if you forgot to add the 1 back in while counting. Answer choice C is just the 700,000. That would be 1,000 times 700 if you forgot to do the 1,001. Choice B is a trap answer if you subtracted 1 instead. I'd like to point out a variation of this problem in which the test might ask you for the sum of all the consecutive even integers or consecutive odd integers. The formula is essentially the same, except you use only the first and last even or odd integer to the average, and then the number of terms will be divided. So instead of taking the first minus the last plus 1, like the original example, you divide that range by 2 first and then add 1. So here's a quick example to wrap this up. Find the sum of the even integers between 4 and 20. Well, the average of the first and last terms is 4 plus 20 divided by 2. That's 24 divided by 2, which is 12. So again, that first step is the same. You find the average of the 4 and the 20. That's 12. Now, what's the number of terms, even numbers between 4 and 20? To get that, you take 20 minus 4 and divide that by 2. So 20 minus 4, 16 divided by 2 is 8. But then you need to add 1, again, just like we added 1 before. So first you divide those by 2 because you're only taking the even ones. There's half as many. So it's the 16 divided by 2 is 8 plus 1. That's 9. There are 9 even integers between 4 and 20, including 4 and 20. So you take the 9 even integers and multiply that by 12, which is the average. That is 108, and done. Now it's time for our word of the day. The word is fracas. Fracas means a noisy quarrel or altercation. A fracas is a loud, messy fight. It creates a disturbance or a commotion. Some synonyms of fracas include scuffle, brawl, melee, tussle, ruckus, or clash. And there are a lot more. We have tons of fighting words in English. So let's use it in a sentence. The following is from a Seattle Times article. Police have said Cardi B, 27, and her entourage argued with a bartender at Angel Strip Club. The dispute sparked a bottle and hookah pipe throwing fracas that caused minor injuries to the women and another employee, according to police. Well, that's pretty straightforward, I would say. This describes arguing at a bar, a dispute, and colorfully paints a picture of people throwing bottles and hookah as a fracas. People were hurt. It's a loud brawl. It's a noisy scuffle. It's a messy altercation. It's a fracas. Okay, that does it for today's lesson. Thanks for listening.